explain how our neck board works in our guitar. So we used 6 ribbon potentiometers in place of strings. In order to do that, we placed copper tape along the neck, and then for the other part of the potentiometer we found that cassette tape is actually resistive. It's 46 kilo ohms per inch. And so by separating that with a foam, we lay that over across the entire fretboard, each one individually. And then we have 5 volts coming into the cassette tape at the bottom, and it's all grounded at the top. And when you press down connecting the cassette tape with the copper tape, depending on where that is, the resistance value in the cassette affects the voltage drop across the circuit. And then that signal is then sent through these signal wires to the rest of our system. And an additional feature that we added is this tuner board here, this screen and these buttons. So 2 buttons associate with each string themselves, and you're able to tune them either half step up or half step down as much as you want to get the desired tuning that you like for your guitar.
So now I want to give a quick explanation on how we actually play a note on the guitar. Brady explained that we can determine what fret we're in for the pitch control of a guitar, but to actually play a note, we use these piezo sensors. They generate a voltage depending on how hard they're struck. They're a metal ceramic element, and when struck very, very lightly, they can get less than 1 volt. When struck very hard, they can get up to 30 volts. Now the Arduino Mega can only tolerate up to 5 volts on its inputs, so we had to engineer a little op-amp circuit that would first filter down the piezo input, and also to get rid of bounce because it did have a very extensive ripple. And so using an RC filter, we were able to get it down to a single pulse from the sensor, and then the op-amp would then actually blow that back up to a maximum of 5 volt range. And along with that, as part of the op-amp circuit, we actually embedded these 6 trimmer potentiometers so that depending on how hard you can hit with each of your fingers, you can actually tune the sensitivity of each individual piezo sensor. This means that if you hit really hard with your pointer finger and your pinky can hardly hit at all, you can change the sensitivity so they actually come out equal.
Alright, so for our system, we decided to use the Arduino Mega as our processing unit. We chose this because it has the 16 analog inputs, and with all of our analog input signals, we needed something that could handle all of them correctly. And also, both of our LCD screen and the accelerometer uses the I2T channel on this, and the Arduino handles it quite well.
So I also wanted to talk about the special effects that we decided to embed in the guitar. Anyone who's ever played the guitar knows that it is fun to just play the guitar, but it's more fun to add special effects. So for starters, we decided to add an accelerometer IMU unit in the headpiece of the guitar. The headpiece of the guitar gets the most motion out of the entire guitar, so if you were to lift the guitar up, that accelerometer would report that to the Arduino, and you could then map that to, say, a whammy effect. The next one I want to talk about, a slide potentiometer like this one would be embedded here in the body of the guitar, so that while you're playing, you could use the side of your hand to hit this slider and actually perform a pitch bend effect. And then when you're done, it would snap back with a spring or something like that. Some other special effects of this guitar, it has a joystick and 3 buttons that actually sit right below your hand as you're playing. The first button actually stays depressed after you push it down, and while it is depressed, will actually let you do sort of a hammer-on effect, meaning you don't have to restrike all of the piezo sensors. Rather, you can just move your hands around on the fretboard, and the Arduino will know that every time it picks up a new fretboard reading, it wants a new note. The other 2 buttons can be mapped pretty much to anything you like. The joystick it's to be able to give you a sort of degree of an effect. So for example, if you wanted just a little of a tremolo effect as opposed to a really heavy tremolo effect, you can actually vary that with the joystick. Some other cool features, just a simple volume knob, really great for playing. And also, we decided to make the entire guitar battery operated so that we could transmit the signals via RF. This means that we don't need any cables off the guitar. Instead, the MIDI signals that it generates can just be transmitted wirelessly to another, say, Arduino Uno connected to your computer that will then feed in those MIDI signals to the synthesizer.